Open any P&ID, and it looks like someone spilled circles all over the page. But here is the thing. Every one of those bubbles, and every line between them, means something exact. Nothing on a P&ID is decoration. There's a standard behind it called ISA 5.1, and once you know the code, the shapes start talking. A plain circle is not the same as a circle in a square. A hexagon is not the same as a diamond. And the line through the bubble, the letters inside it, the line that connects it to the next one, all of it is information. In this video, I will decode the symbols an automation technician actually reads. First the bubble shapes, then the tag letters inside, then the line types, then we trace one full loop. By the end, you will read P&ID symbols without reaching for the legend. Quick note first, a P&ID is the drawing, not the PID controller inside the PLC. Same 3 letters, different thing. The controller has its own video, link below. Quick note before we dig in. This is from PLC Simulator, where you can read P&IDs and practice the PLC side of every loop free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now back to the bubbles. Start with the instrument bubble. The shape around it tells you where the instrument lives. This is the heart of reading P&ID symbols. A plain circle is field-mounted. It sits out on the pipe or the vessel where the process is. A circle inside a square is a DCS or shared display function. That is something an operator sees on a shared screen. A hexagon is a computer or software function, a calculation, not a physical device. And a diamond inside a square is a PLC function. So before you read a single letter, the outline already tells you field, DCS, computer, or PLC. Then there is a second clue, the line drawn through the middle of the circle. A single solid horizontal line means the instrument is on the main control panel, accessible to the operator. A dashed line means it lives behind the panel, present, but not normally accessible. No line at all means local, field-mounted. So the shape gives you the technology, and the line gives you the access. Now the tag inside the bubble. This is the part that carries the real meaning, and it follows a strict order. The first letter is always the measured variable. F is flow, P is pressure, L is level, T is temperature. That first letter tells you what the loop is about. The letters that follow are the function. I means indicate. C means control. T, in the second position, means transmit. So put together, FIC means flow, indicating controller. Add the loop number, and FIC 101 is the flow indicating controller on loop 101. FT 101 is the flow transmitter on the same loop. LV is a level valve. PIC is a pressure indicating controller. First letter, what is measured. Following letters, what it does. Number, which loop. Decode that, and you can name any instrument on the drawing without a legend in sight. Now the lines that connect the bubbles, because the line type tells you how the signal travels. A plain solid line, usually heavier, is the process itself. Actual pipe carrying actual product. The instrument signal lines are thinner and marked. A line with little slash marks across, it is a regular electrical or analog signal. Think 4 to 20 milliamps between a transmitter and a controller. A line drawn with small circles or a dash pattern is a software or data link. That is a digital connection, a field bus, or a network between controllers. And a line with crosshatch marks is a pneumatic signal. Air pressure, the way older final elements were driven. So one glance at the line, and you know whether you're looking at pipe, an electrical signal, a data link, or air. That is the difference between guessing and reading. Last piece, valves, and then we put it all together. The valve body is a simple bow tie on the process line. The actuator on top tells you how it is driven. A dome is a diaphragm actuator, usually air-operated. A little box is a motor or solenoid. Now trace one full loop and watch the symbols do their job. Out on the pipe, a plain circle tagged FT101, a field flow transmitter. An electrical signal line slashes across it, runs from that transmitter to a bubble on the panel, FSC 101, the flow indicating controller. From the controller, another signal line runs to a valve with a diaphragm actuator on the process pipe, the final control element. Transmitter measures, controller decides, valve acts. You just read a complete control loop straight off the symbols. For the wider P&ID overview, equipment, piping, the whole drawing, I have a separate video linked below. This one is the symbols deep dive. So here's what to walk away with. The bubble shape tells you where the instrument lives. Circle is field, circle in square is DCS, hexagon is computer, diamond in square is PLC. The tag inside tells you what it is. First letter the variable, following letters the function, number the loop. And the line type tells you how the signal travels. Slash is for electrical, circles for data, crosshatch for pneumatic. 3 layers of code. That is all P&ID symbols really are. And once you see them, every P&ID on the floor opens up. Now, go make it concrete. If you want to read P&IDs and practice the PLC side hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.